Okay, you should now be on page 45. Turn to page 45. It looks like this. Yes, we're skipping a few more pages again. So skip ahead to page 45. The page number's right next to this picture of a Gatorade bottle down here, if you're having trouble finding it. We're going to talk about the ways you can classify matter. So, first of all, let's talk about everything. A lot of science involves describing the universe, and to do this we have to classify the things that we encounter. So, everything in the universe is either energy or matter, or some combination of the two. Energy is the capacity to do work. You can see energy as light, you can feel energy as heat, but you cannot touch it or smell it. Matter is anything that has mass and takes up space. You can touch it, feel it, taste it, smell it. That's matter. We're going to not worry too much about energy right now. Energy we're going to come back to in our very last unit at the end of the year. For now, for almost the entire year, except for that last unit, we're going to focus on just matter. And to do that, we need to start by talking about how we can define matter, besides just has mass and takes up space. Matter can be a pure substance, where there is only one kind of matter. And if you're going to separate it, you have to do it chemically. Bonds have to be broken. So pure substances can be elements, which are found on the periodic table. And made of one type of atom. We've talked about elements a couple times so far already this year. And you can see here we have one kind of atom. These are the same shade of gray. This whole cube is a whole bunch of atoms, different individual atoms, but they're all the same kind as each other. That's an element. Versus in a compound, you have two or more elements held together by chemical bonds. Compounds have a fixed composition, and they cannot be separated by physical means. So when I say a fixed composition, think of it as looking at down here. This molecule right here, there are two different elements, I know, because these two atoms are the same as each other. They're the same size and color. This one is a different one. I know because it's darker and a different size. Because I have two different elements, here's one element, here's a second element, held together by chemical bonds, they're all smushed together, that is what tells me this is a compound. It has a fixed composition, meaning there's this like 2-to-1 ratio of the thing we have two of the same and one different thing. That's a fixed composition. In this bigger picture, it's a little harder to see, but you can, if you look closely, see that there's some of the atoms that are bigger and some that are smaller. It goes like big, small, big. Like if you had a whole bunch of these stacked together. The colors didn't come out super well, but if you look closely, they are different sizes. That tells me these are different elements as well, stuck together. And in a compound, you cannot separate those elements from each other by physical means. You have to do a chemical reaction. So by physical means, a physical change will not separate the elements from each other. A physical change won't separate the elements. Let's zoom back out a little bit. So that's are two types of pure substances, let's talk about mixtures. Mixtures are formed when two or more substances are physically combined, meaning some physical change. Like usually they are literally mixed together. All substances in a mixture retain their own properties. They can be separated physically with a physical change. You can pick them apart. Some ways to physically separate would be literally picking apart. You could also filter, or you could distill. You could also do something called a centrifuge to separate the mixture. You may have talked about centrifuges in biology. It's a way that you can like swirl stuff around and it'll separate by like density. If you have a centrifuge that works correctly. There are two kinds of mixtures, homogeneous and heterogeneous. This prefix homo is a prefix you should know from biology, like the word homozygous. That prefix homo means the same. Where each sample that you take will be the same as the others. Alloys are mixtures of two metals. Some examples are steel, brass, and bronze. And you know a homogeneous mixture because it looks the same all throughout. You cannot see differences with your naked eye, like in these alloys. Steel is actually iron and carbon mixed together. Brass and bronze are like zinc and copper is one of them, and I think the other is tin and copper. If you look at a sample of steel, you can't tell which parts are iron and which parts are carbon. You can't tell which parts are zinc and which parts are copper when you're looking at bronze. To your naked eye, you can't tell that there are different things mixed in there. Same idea with like vanilla ice cream. Every scoop of vanilla ice cream is the same as all other scoops of vanilla ice cream. That is a homogeneous mixture. Or like a smoothie. A homogeneous mixture, and this is the key thing, is well mixed. A homogeneous mixture is well mixed. It's been mixed together so well that every sample you take is the same as all the others. If you drink from the top of your Gatorade bottle or you stick a straw in and drink from the bottom, you're going to get the same exact stuff because it's well mixed. A heterogeneous mixture is poorly mixed. That prefix hetero, again, you should know that from biology, like the word heterozygous. That prefix hetero means different. Each sample that you take will be different from the others. It looks different throughout to your naked eye. You can personally see differences, like a salad. You can see all kinds of different stuff in a salad. It looks different. You can see where one part is different from another part. When you're done writing that, let's turn the page to page 46. An element, again, is only one type of matter, one type of atom. All the atoms are the same as each other, like helium. You can find elements on the periodic table, and I want you to right now look at your periodic table that's on the back of your book and pick any 3 elements. I don't even care which 3. Pick 3 and write down your 3-element examples. Go ahead and write their names and their symbols. Helium's already on there. Pick 3 different ones and write them in. Okay, compounds. There's still one type of particle. It's a pure substance. All the particles are the same as each other, but those particles are molecules that have different individual atoms. They're just stuck together in the same way. So like water, there's always 2 H's and 1 O stuck together. H2O, 2 hydrogens and 1 oxygen stuck together, always. That's a compound. Some other compounds you may know: salt, table salt, that is sodium chloride, NaCl. Another one you may know, glucose, that is C6H12O6. Some other ones you may know. There are all kinds of compounds out there, but I'm going to go with ammonia, which your mom might use to clean stuff. It's this like kind of yellow cleaning solution that smells terrible. That's NH3, 1 nitrogen, 3 hydrogens. Heterogeneous mixtures are poorly mixed, like wet sand. You got water, one kind of molecule, you got sand, a different kind of molecule, and they're not mixed very well. Everything in there has its own properties. The water molecules have all the properties of water. The sand molecules have all the properties of sand. Other examples of heterogeneous mixtures may be like a fruit salad. Every piece of fruit in your fruit salad is different from all the other fruits. They have their own properties. The pineapple doesn't start suddenly becoming a honeydew melon just because it's sitting next to one in your fruit salad. The pineapple's still a pineapple. The melon is still a melon. Another example would be something like chocolate chip cookie dough ice cream. Where if I take a scoop on one side, I might get a spoonful that is just the vanilla ice cream. If I take a spoonful from another side, maybe I'm going to get 2 pieces of cookie dough and a chocolate chip in there and almost no ice cream. I'm going to get totally different samples because it's poorly mixed. And another example of a heterogeneous mixture would be like gravel. You got all kinds of different rocks in a mixture of gravel. No 2 of them are exactly the same, and you can see physical differences from one piece to another piece. A homogeneous mixture would be like tea that has sugar dissolved into it. You've got water molecules, you've got tea molecules, you've got sugar molecules, and they're all mixed together. If you've dissolved the sugar into the tea properly, then every sip of tea is going to be the same as all the other sips. It is well mixed and a homogeneous mixture. Another example would be like coffee. Whether there's sugar or milk in it or not, whether you're drinking it black, whatever. If you've mixed it, then all of your sips of coffee should be the same as all your other sips. It's a homogeneous mixture. It's well mixed. Some other ones you may know would be like if you've got salt water or vinegar. Those are mixtures. Vegetable oils, another one. It's a mixture of oils from several different kinds of vegetables, and the top of the bottle and the bottom of the bottle have the same stuff in it. When you get to the end of the bottle, you're still using the same kind of oil you had when the bottle was brand new, because it was well mixed. So we're going to practice together identifying element, compound, heterogeneous, or homogeneous for these mixtures. Pizza. Is pizza well mixed? If I take a bite of pizza, is it always going to be the exact same as all the other bites? No. Even if it's a normal cheese pizza, some bites may have more cheese or more crust or more sauce. That's poorly mixed. That's a heterogeneous mixture. Gold, and then we've got the symbol AU. That's a element symbol on the periodic table. If it's on the periodic table, guess what? It's an element. Okay, sugar. And then again, we've got a formula. There's 1, 2, 3 capital letters that tells me 3 different elements together in one big compound formula. When you have one formula together like this, that is going to be a compound. Water. Again, I see 2 different element symbols here. I know they're 2 different elements because I've got 2 capital letters. This is a formula for another compound. Sodium bicarbonate. That's baking soda. I've got sodium, hydrogen, carbon, oxygen. Again, I know these are all 4 different elements because I got 4 different capital letters. I always see people who will see this and tell me that that's cobalt, but it's not, because cobalt would be C with a lowercase o. This is a capital C carbon and a capital C oxygen. Regardless, I still have multiple elements stuck together in one formula. That's another compound. Iron, and I've got another symbol, Fe, only 1 capital letter. That tells me maybe I should go double check on my periodic table. Oh, that's an element. Iced tea. This is a tricky one. Tea, in general, should be a homogeneous mixture. If you've brewed your tea properly, all your sips will be the same as all the other sips. But if you add ice into it, that suddenly makes it poorly mixed. Some of the samples have ice and some of the samples don't. And when it's poorly mixed, that's heterogeneous. The ocean. You got some salt water, but you've got other stuff in there. There's like fish and whales and algae. And a sample of the ocean in Galveston is going to be very different from a sample of the ocean in Australia. That's also poorly mixed. That's a heterogeneous mixture. Brass. And then it says copper/zinc. That slash is what tells you this is an alloy. And if we go back and check our notes real fast on page 45, we talked about alloys as a homogeneous mixture. And there were even some examples down here with that slash in it telling you, hey, these are homogeneous mixtures. These are alloys. All right, at this time, you are now ready and capable of doing page 47, which was also part of your stamp for the day. Again, I'm going to hand it over to Miss Woodlock, but this is your last video for the day.